All right, today we are solving quadratic and other polynomial equations by factoring. I kind of got rid of some words so you can abbreviate it a little. You don't need every word there. This is section 6.8. And it's the whole reason we've learned to factor. So the first example, I don't want you to write. I just want to talk about it. When we have a linear equation where x is to the first power, generally, we only have one solution. If not, no, we either have infinite, one, or no solutions, right? And we solve it by getting x alone. So we add 10 to both sides. We use inverse operations. So when 5 is next to x, we instead of multiplying, we divide. And then we get x is equal to 2. One solution. With a quadratic, when you see x squared, 90% of the time you're going to get two solutions. If you add a cubic function to the third power, you're likely to have 3. The only time you're going to have not have two solutions here is when you end up getting a perfect square trinomial, and I'll show you that in a little bit. So we can pretend right now this is the same thing we've been doing, only it's set to equal 0, okay? So in your notes, on the left-hand side, okay, on the left-hand side, I'm going to just erase this for a minute. Okay. So, over here, you're going to give me the directions, okay? So temporarily, the first thing you're going to do is we're going to factor the left side. Okay? What form of factoring can we do? GCF.
Unknown caller.
GCF. And that would be?
X.
Okay, I'll do x times what?
The quantity of x minus 5.
X minus 5 equals 0. Now, you're not doing anything right now, just listen to me. For a long time, you've been using what's called the zero product property. Okay, and that property says that if a quantity times a quantity equals 0, that either one of those quantities has to equal 0, right? Yeah. You've been doing that since 3rd grade when you learned your multiplication tables. I know if two things multiply together, if they equal 0, then one of those factors has to equal 0. Well, we're going to use that right here, and it's called the zero product property. And what we're going to do is take both factors and set them equal to 0. I don't really need the parentheses once I've factored. Set them both equal to 0. Okay? So number 1, we're going to factor. I'm going to actually move this down here. X equals 0 and x minus 5 equals 0. And okay, number 2, we're going to set both factors equal to 0. Okay? So here's the first factor, and here's the second factor, right? Those are the two factors. There's nothing we have to do here. Okay, but here I have to get x alone, so I'm going to add 5, okay, and then I get x equals 5. So my solutions, I put them into a solution set. Number 3, solution set. My factors are 0 and 5. So step 1, I factored. Step 2, I set my factors to 0. Step 3, I got x alone in each equation of my factors. And then step 4, I'm using those as my solution set. Yes, question.
I just don't get why you're allowed to say that x is equal to 0 and 5.
Well, let's see if it works. Okay, you can always check it. because we're using the zero product property. If it's set, oh, didn't mean to do that. Forgot I erased. Okay, so I can check it, right? Let's check if x is 0.
0 squared is 0.
0 squared minus 5 times 0, does that equal 0?
Yeah.
Okay, then let's try 5 squared minus 5 times 5, does that equal 0? Works.
Ooh.
Okay?
Oh, so it could be 0 or 5.
Yeah, but not at the same time.
What?
Not at the same time.
I don't understand.
Like you can only if you're gonna use 0, try it in both x's. If you're gonna use 5, try it in both x's. Okay, let's keep going. Can I erase this? My directions, did everybody write it down? Oh, the one on the right, now I want you to write all this. Pause the recording and write this. All right, so somebody wants me to go back through it. Temporarily, Aton, okay, how would you factor this? Wait, sorry. How would you factor just x times x minus 5?
X times x minus 5.
I'm sorry, x squared minus 5x. How do you,
I'll look for a GCF.
which is,
X.
and then what's left here? When you divide an x out, what's left?
It's x minus 5.
Good. And then we just, it was equal to 0, right?
Yeah.
2 equals 0. Now, this is a factor and this binomial is a factor. I'm setting both, since they both multiply to 0, I'm going to set them both equal to 0.
What?
Because either,
Like, 5 does not equal 0, though. Oh.
I'm setting, shh.
Yeah, but there's a subtraction sign.
Okay, but I'm setting the binomial equal to 0. I didn't set 5 equal to 0. I'm setting the factor equal to 0. So now,
Why?
because I'm using my zero product property, since this is equal to 0, that means either this or this factor has to equal 0, since this equals 0.
I mean, x minus 5 doesn't equal 0.
Okay,
even
start
if-
writing the zero product property factor below.
What is 5? What is x?
Now, in your left, on the left of your notes, I want you to call it zero product property. On the right, I want you to put this definition. Okay? Pause it and make sure you're writing down the zero product property. Okay, here we go. So now they're kind of setting us up with it already factored. So on the first term, I have factor times factor equals 0. So I'm going to set both factors equals 0, and then I'm going to set x plus 7 equals 0, and I have to solve them.
Okay.
I'm adding 4. X equals 4. On the next one, what do I have to do to figure it out? What do I do? Come on, subtract 7. And x equals negative 7. Okay? So my solutions, they go in a solution set, and that would be x equals 4 or negative 7. Usually I put them in order from least to greatest, but you don't have to. Yes, David? So
Didn't you say only one of them has to equal 0?
we set both factors because there's two solutions.
Yeah, that's what I was gonna ask.
What?
That's what I was gonna ask.
There's two solutions. It started out as x squared. Oh, well, you don't know that, but all right, try the next couple. Go. Pause the recording. Okay. And you can always check yourself. So if I were checking myself now, x minus 7, I'm sorry, x minus 4. The original problem is x minus 4 times x minus 7 plus equals 0. So if I substitute, let's say, negative 7 in, negative 7 minus 4 times the quantity of negative 7 plus 7. Okay, this equals 0 times negative 11. What does that equal to? What does it equal to? 0, right? I can try substituting the 4. 4 minus 4 times 4 plus 7 equals 0. So it's 0 times 11 equals 0. Both solutions work. Okay? So you,
Should there be 3 solutions?
what?
Is there 3 solutions?
Yes. So the question is, are there 3 solutions in X? Absolutely.
Michelle, I'm sorry.
Yep.
Um,
Pause the recording, finish the... Okay, let's check our work on number 2. I set X equal to 0. There's no work for that. And X plus 3 equals 0. Now, I'm okay, like, in the next step, I don't need to see you subtract 3 from both sides. You understand? If it's a one-step method, you can just tell me X equals negative 3. If it's 2-step, I want to see the math. So my solutions for number 2 were 0 and negative 3. Okay, number 3, I'm setting 3x equal to 0, x minus 1 equal to 0, and x plus 4, 3x and x plus 4 equals 0. Okay, and I'm dividing by 3, x equals 0, x equals positive 1, x equals negative 4. I like to put my answers from least to greatest because I'm a math person and that's what we do. But you don't have to. It just would be nice for the teacher who's grading your work. Now you'll notice on the last one, I do expect to see your work. Okay? Notice I have the 2-step. I'm going to add 5 to both sides, divide both sides by 2, and stop there. Don't convert it to a decimal or a mixed number. It's one more step where you could potentially make a mistake. If I accept a reduced improper, leave it like that. You understand? Because statistically, if you have the right answer and you go one more step and you're distracted, it's one more chance of you getting it wrong. Okay, questions? Yes.
So we just leave it as an improper?
Yes, reduced improper.
Well, if... Oh, yeah.
I'm going to skip these because this is a lot of the same. Now, the only way at this point you know how to solve is through the zero product property. This is how you're going to see the problems. So, the first thing you're going to do is, what did we say before? Factor. Is there a GCF?
No.
No, there's no GCF. And this is just general trinomial factoring. So I'm only factoring the left side, what multiplies to negative 12 and adds to negative 4. What is it, Bryce?
Negative 6
Oh,
and 2.
negative 6 and...
Good. So now I'm factoring that to x minus 6 and x plus 2 equals 0. And now I'm factored. I set them both equal to 0. X minus 6 equals 0. X plus 2 equals 0. All right, add 6, x equals 6, subtract 2, x equals negative 2. My solutions are negative 2 and 6. Now, I can always check it. 6 squared minus 4 times 6 minus 12. Does that equal 0? 36 minus 24 minus 12 equals 0. 36 minus 36 equals 0. It works. Let's try the other one. X squared minus 4x minus 12 equals 0. 2 squared minus 4 times 2 minus 12. Does that equal 0? So that's 4 minus 8. What happened there? Oh, it's negative 2. So it's positive 8. and minus 12, does that equal 0?
Yes.
That works. So both solutions work. Okay, questions? All right, why don't you try the next one, but don't forget to check your GCF. Pause the recording. Okay, let's check our work. Follow the chart. What's the first thing you do? What's the first step up there on my chart on the wall?
GCI.
Thank you. Alan, what's the GCF?
5.
5 and what?
5x.
Good. I'm going to divide out a 5x
And you get x to the second
plus 4.
x plus 3.
Good. Okay, I'm not done factoring. I can still factor this trinomial. Okay, what multiplies to 3 and adds to 4, Alan?
3 and 1.
Good. So now I have, this is factoring to x plus 1 times x plus 3 equals 0. And don't forget your GCF. So now I set them all equal to 0. 5x equals 0. X plus 1 equals 0. And x plus 3 equals 0. Elizabeth, do you have a question?
No.
Okay, David, do you?
No, she answered.
Okay. So on the first one, x equals what?
0.
Good. On the second one, x equals?
Negative.
And on the third one, x equals?
We don't have to.
Negative 3. If it's a one-step, I'm okay with you skipping. If it's a two-step equation, so my solutions are negative 3, negative 1, and 0. Put them in order if you want to make your teacher happy.
Like, wait.
They don't have to be. What?
So, would the math book put it in different orders? Like,
They'll likely give it to you in
in the, like, order, like,
least to greatest.
least to,
Okay.
least to greatest?
So, notice that this is, when we have something squared, how many solutions do we have?
2,
When I have something cubed, how many solutions?
3,
Okay? When it's to the first power, we likely have 1. Oh, sorry. First power, we have 1. Sometimes we have infinite or no solutions, but those are rarities.
Which ones are infinite?
When you get like 5x equals 5x, any number will work for x.
Wait,
Okay.
when are we going to get 5?
We've already done it. Let's continue and stay focused. Okay, do you want to pause this and try the next two?
Yeah.
Pause the recording. Don't forget your GCF. Okay, good. Pause the recording, try the next. Okay, let's go. So step 1, what do we have to do? How about Matthew?
Factor.
Factor what?
X.
X, and what's left?
X squared minus 100.
Good, and then?
You do x times.
We don't do, we factor more because that's a difference of squares. Use the terminology. It's the only way you'll get to know it. Go on.
X.
What are you going to say to me?
Factor.
Factor what?
X squared minus 100.
What's it called?
The difference of squared.
Thank you. I want to hear that. Okay, go on.
X times x minus 10 times the quantity of x plus 10.
Perfect. Now, set them all equal to 0, and my solution is negative 10, 0, and positive 10. Okay, Rami, next one.
So we can factor it to x minus 5 squared.
Good. He recognized right away that this is a perfect square trinomial. He didn't even have to do the x marks the spot. But if you want to, it would have worked. It just is faster if you know. So he's noticed that this is plus 25 and negative 10. It's negative 5 and negative 5. He said it's x minus 5 squared.
And
Right?
I only wrote it once because
Well, no, you have to write it twice. Okay, because you've got to factor it out. And then x equals
x minus 5 equals 0 instead, so x equals 5.
x equals 5. We don't have 2 5s in our number system.
Yeah, that's
So
why
we only write 1 5 at that point. Okay? Because there aren't 2 5s on the number line. This is just where's the solution in the number system. Okay?
So
You don't write it repeated.
if you write something like this on the pop quiz,
And you write 5, 5, I'm going to mark you off.
okay.
Okay?
But you have to write the x minus 1.
What?
You have to write x minus 1 too.
Yeah, but he's saying what happens if you put 5, 5? I'm going to mark you off. All right, let's continue. So on the next one, what do we need to do?
Common factor
GCF of A.
is A.
Guys, tell me the kind of factoring. I want you using the words.
Factor.
Okay, now, what kind of factoring do I have, Alex?
I forgot the name. You have to do
Okay, then I want to see hands up if the name. Go.
Difference of squares.
Factor the difference of squares. Use complete sentences. Okay, so tell me one more time, Alex, try it again. What do I do next?
difference of squares.
I factor the difference of squares. Go again.
You factor the difference of squares.
Okay, and how do I break that down?
A times the quantity of A plus 3 times the quantity of A minus 3.
Yep. And then we get 3 solutions. A equals 0, A equals -3, and A equals +3. Over here,
Wait, what? Oh, yeah.
okay, we're going to have all kinds of factoring. Remember when we have a lead coefficient? And we're going to go down to, okay, I'm going to go down to here. So I get x squared plus, remember I'm doing my lead coefficient factoring, minus 60, right, equals 0. What multiplies to -60 and adds to +11? Yep, go.
So we can. Oh,
Okay.
5 and no.
Okay, who has it?
Wait, can't you use
Go.
15 and 4, negative.
15 and -4. So I'm going to factor it by doing x minus 4 times x plus 15. Oh, am I done?
Divide by 6.
Plus 15. I have to divide both sides by 6 and reduce. 2 goes into that twice and 3 times, and that becomes 3x minus 2 times the quantity of 2x plus 5 equals 0. Now we set them both equal to 0. 3x minus 2 equals 0. 2x plus 5 equals 0. I'm adding 2. Divide by 3, and x equals 2/3. I'm subtracting 5. 2x equals -5. Divide by 2, and x equals -5/2. So my solutions are -5/2. Make sure it's clear. Look at my answer. Looks really awkward. And 2/3. So you're going to have all kinds of factoring. Is everybody good with that?
Yes.
We need to keep going. Stop. Okay? Couple more problems.
Wait.
Do not pack up. Okay, right here. I've only taught you to solve at this point with zero product property. So how do you think we set that equal to 0? What would I have to do, Bryce?
Maybe add 45
Right, just move it over. Add 45n to both sides, then GCF. Now I've got 5n times n plus 3 times n plus 3, equals 0. So I set 5n equal to 0 and n plus 3 equal to 0. In this case, how many solutions do we have even though it was to the third power?
3. 2.
N equals 0 and n equals -3. Because these two are exactly the same. I don't need to write them twice. On the next one, hold on. On the next one, what am I doing? Send it over to the side where the x squared or the biggest x is. Minus 49x minus 49x. And we are left with 4x cubed minus 49x equals 0. You guys with me? I'm going to just go here. So if I subtract 49x, now we have to GCF x. And I'm left with, what's that called? A difference of squares. So
2x plus 7, 2x minus 7.
2x plus 7, 2x minus, x equals 0. X equals negative 7 over 2. I do expect you to do the math for 2x plus 7 and 2x minus 7. Okay, that's it. Don't forget your GCFs. You can go back, pause the recording, try these next two. Now check. That's the lesson. We're out.